Good morning, ladies and gentlemen. You should have watched the Eureka video first. If you haven't done that, watch that first and then continue watching this video. The accelerometer, our good friend, has a bubble that shows the direction of the acceleration. How does it do that? Well, first of all, bubble right here, water down here, and the bubble is going to point in the direction of the acceleration. So as I move this way, the bubble is up here at first. That's the way I'm accelerating.
Yep.
And then I slow down. Goes the back, decelerating. Okay, negative acceleration. But anyways, it points
Didn't
in the
we use
direction.
that in the car the other day?
We did. And when I push the gas, vroom! And then when I push the brakes, right?
That's right.
And it sloshed up against the front when I push the brakes on because I'm accelerating in the negative direction.
Yeah.
But how does it do this? How does it do this? Well, the water has mass. Ew, you can see all the stuff inside there. Can you see all the speckles?
Yeah, that's because that water and the food coloring has been in there for 25 years.
So the water has mass, and the more mass you have, the more inertia you have. More mass, more inertia, more resistance to change. And so what happens is when we first start moving, the water is like, nah, I don't want to move. So it sloshes up against the back.
It wants to stay where it was.
It wants to stay where it was.
And that plastic thing is moving. It wants to stay where it's at.
See, it wants to stay back here. It's like, no. And then once we get going, then in the front, the water's moving, so it wants to stay moving, slosh up against the front.
There you go.
It's annoyed with me. So this is my accelerometer. A bubble points in the direction of the acceleration.
So it's really not the bubble, it's the water.
Yes. Bubble cart. A bubble cart is pushed and coasts to a stop. What does the bubble do? So we want to pay attention to the bubble. You guys will be in this room soon. Some of you. Gotta clean up a little bit.
We call this a bubble cart because it's got a bubble in it.
Mm-hmm. Water, bubble in the middle. And pay attention to what happens when, what does the bubble do? So right now it's stopped. What's it doing?
Nothing, just sitting there.
Okay, now I'm gonna push it. Okay, let's do that again.
Well, there's 3 phases. Let's look at the 3 phases and then we'll do it again. Because that was pretty good.
That was pretty good. Okay, so 3 phases. Push, coast, stop.
So while she's pushing, while it's coasting, and when it stops. So when it's coasting, it's slowing down, right?
Yeah, when it's coasting, I'm letting go of it. It's like if you take your foot off the gas pedal when you're coasting, right? You need cruise control if you want to stay at that speed.
That's right.
Okay, so first of all, it's stop. Bubble does nothing. I'm gonna push it. What does it do? And I'm gonna let go of it. What does it do? Oh, that was perfect.
Oh, and then when it
Stop.
stopped, ooh.
Back to the middle. I think we're good.
Yeah, I think they should write down in their notes what the bubble did when you had your finger on it pushing, what the bubble did while it was coasting, and then when it came to stop, what did the bubble do? And if you can't remember, run the video back.
Run it back again. Watch again. That was literally so well executed. Well done.
Yeah.
Okay. Good job, Smart. Okay, so there's 3 phases: the push, the coast, the stop. And now we are going to, if you have not got that figured out, the push, the pull, the stop, watch the video again. That's important. Does the bubble go forward? Does it go backward? What's it doing? Is it in the middle? Tell me.
So things are going on kind of quickly. We need something that'll help us analyze and understand what's going on, and that thing is
A free body diagram.
Yep.
And that is a dot with arrows that represent vectors.
vectors. Ooh, ooh, ooh.
Not your direction. Okay. So we'll go ahead and we'll do stopped. And then we'll do push. And then we'll do coast. Now don't forget, it's slowing down when it's coasting, right?
Yeah.
Because of the friction.
Yeah.
Oh, we haven't talked about that yet.
Yeah, we'll get to that.
Okay, so it says dots and it says arrows and a dot. So first of all, this dot is going to represent our cart because we don't need to draw out the cart every time. That's just obnoxious.
Some people have great artistic talent, but
I am one of them.
We're not going to draw a cart. Who represent would have done?
Okay, so my first question. It says, what forces are acting on a bubble cart when it is at rest on the table? So stopped, at rest, and I'm going to use green for God's good green earth.
That's right.
And blue pointing towards the sky.
What's that thing that prevents me from dunking a basketball?
Gravity.
That's gravity.
Okay, so gravity is down towards the center of the earth, right? So I'm just going to go ahead and draw an arrow like this. Force of gravity. What forces are acting on the bubble cart when it is at rest on the table? What else?
Well, it's not falling through the table, so there must be a force in the up direction.
Yeah, so if gravity is pulling it down, then there must be something also pushing it up.
Yep.
So I'm gonna draw a arrow, and it's gotta be about this. It's gotta be the same size, right?
Yes, ma'am.
The force up, we'll call it.
Up.
Up. Okay, so I think those are the only forces.
I think that's it.
Okay. Now, have we talked about? We didn't talk about the equal and opposite.
Not yet.
So,
I mean, that's okay.
Okay. Sneak preview.
That's third law.
While you are pushing a bubble cart, what forces are acting on it?
Oh, okay.
So push. Now, we're going to have the same exact forces as
It's still on
these,
the
right?
table and gravity's still pulling down.
Yeah, so I'm going to go ahead and, let's see, same
The table had better be
size.
pushing up. When it rolls off the table and falls to the floor, that's because the table's not under it pushing up anymore.
Yeah, okay, let me do this a little bit more accurately. It doesn't have to be perfect, but, you know, you want your arrows to be the same length because the arrow represents the number, the magnitude of that thing, right?
Force of gravity is not changing.
No. And the FUP is also not
Fup.
changing. The FUP. Okay, but what else? We're pushing it, right?
There's the force of the push.
Okay, the force of the push was in that
Yep.
direction.
Don't use red.
Oh, red? No red?
Red will stay for that other
Let's
thing that
do
starts with F.
Okay, so I pushed it. Force of the push. We'll call
Push.
it. That's a cute purple. Okay.
It is.
Anything else on this?
I think that's it. You're pushing on it.
Okay. All right. If the bubble acts as an accelerometer.
Oh.
Huh. Okay. We accelerometer. That was an accelerometer.
And what did the bubble do while she was pushing on it?
It pointed in the direction of the acceleration. Well, for this, so what did it do? What did we see happening here? Well, what direction did the bubble
The
go?
bubble went forward.
The bubble went forward.
So the
Ooh.
acceleration should be also forward.
So the bubble went, ooh, this is a cute color too, Miss Moore. Thanks, guys. Okay. So the bubble acts as an accelerometer. What direction? What is the direction of the acceleration? What is the direction of the net force? Okay, so the bubble went this way, which means that my acceleration was also this way.
Yep.
Okay. What is the direction? What is the direction of the net force?
Well, net means the sum, the total, so that up and the down cancel each other out.
Just cancel.
There's only one force left.
Force net. It's gonna be that way too. Which
Agreed.
makes sense. Like that's the way I'm pushing it. That's the way it's accelerating. That's the net force.
That makes sense.
I think this is the first time we're talking about this.
It might be.
If you're confused, it's okay. What forces are acting on the bubble cart while it coasts to a stop? Okay, so
Some things are the same.
some things are the same. So we know our force of gravity is going to be the same. So right around here. And it's not flying off the table, so we know our FUP is the same. Okay, they're all equal. Now I'm no longer pushing it.
Nope. So
Right.
if you're not touching it,
Well, why does it slow down?
there must be something resisting its motion.
Huh. We are gonna, what are we gonna call that? We call it the force of friction?
I think that's friction, yeah.
Okay, so friction is kind of like when you rub your hands together and it gets hot.
Yeah.
Okay, that drag that we get. So we're gonna go ahead and just draw it like this. Force of friction.
Okay, and that's the only forces because you're not pushing on it anymore.
Yeah, so do I have the same questions on my next
You
slide?
do.
Yeah, what is the direction of the acceleration now?
Well, what did the bubble do? When
Well-
as soon as you took your finger off of it,
No, check me, you guys. I'm not lying here. The bubble went back.
It did.
It goes back. And so that means that my acceleration is this way. What does an acceleration that goes backward mean?
It's a deceleration.
It's a deceleration or a
Negative is better.
acceleration. Negative acceleration, slowing down, right? Slowing down, negative acceleration. You're like, aha, all those practice problems we've been doing, they make sense. So let's take a look at this force net. Now, these ones cancel out again, right?
Yep.
And our force of friction is the only one
That's
left.
the only one left.
Now, the net force is always in the same direction as the acceleration.
Yes, it is.
Write that down. Okay, that's important. The net force is always in the same direction as the acceleration. I'm sure we'll talk about that again later. That's it. Do we have homework?